Welcome to Project 1 in Advanced Math Applications. What you see right here is the 5 learning targets that we'll focus on in this unit. However, we're only going to focus on the first 3 in this lesson. These 3 targets focus on the variables involved in linear regression. The first target is I can identify the independent and dependent variables. The second target is I can identify the type of relationship between 2 variables. And the third target is that I can state the reasonable domain and range of a relationship. Before getting into any of that, we need to first understand what linear regression is. This takes us into the mathematical world of statistics. Linear regression is a statistical technique for modeling the linear relationship between 2 variables. This is also known as the line of best fit. I know, that's a little confusing, so let's break it down. A statistical model is a graph that tries to explain why data is behaving the way it is. We've certainly seen this all over the news during the coronavirus pandemic, but this is also used in other areas of science, business, psychology, medicine, engineering, various types of manual labor, education, and even sports. If you want to see the relationship between 2 variables, you can put them on a scatter plot. So you put one variable on the x-axis, one on the y-axis, and you see what shape the data has. There's a lot of different shapes this data can take, and if you try to draw a line or a curve through the data shape, this is called a regression. A linear regression is when a straight line can be used as this model. The value of a linear regression is that it explains data that you already have and allows you to make predictions about data that you don't have. This is something we'll explore further in the next lesson. For now, let's get back to those 3 learning targets and talk about the 2 variables involved in a regression. Here you see the definitions of independent and dependent variables. An independent variable is a variable whose variation does not depend on the other variable. A dependent variable is a variable whose variation does depend on the other variable. In this lesson, you'll be asked to compare 2 variables and decide which variable would be the independent and which would be the dependent variable for a given situation. For this particular example, we're being asked to compare the sprint time and long jump distance of a particular athlete. The way the question at the top is asked actually matters. It says, do faster runners jump further? In other words, it's asking, does the speed of a person impact how far they will jump? By definition, the dependent variable is the variable that depends on the other variable. In other words, it's the variable that's being affected. Since we're trying to see if jump distance is what's being affected, that would make that the dependent variable. And then we're left with, obviously, sprint time as being the independent variable. Now let's move on to the types of relationships we're going to see between 2 variables. The first type is a positive relationship. In this relationship, as the independent variable, also known as the x, increases, so will the dependent variable, the y. So what you'll see is like a positive directed line. It is also true to say that as the independent variable decreases, so will the dependent variable. The next type of relationship is a negative relationship. Here, as the independent variable increases, the dependent variable will decrease. This will show up as a negative facing line. In addition to positive and negative linear relationships, there's also nonlinear relationships, and in some cases, no relationship at all between 2 variables. Taking another look at the data from example 1, we could be asked whether or not this is a positive or a negative relationship. What we see is in the left-hand column, or the independent variable, as the numbers go up and get larger, we're seeing that in general, the right-hand column, or the dependent variable, is going down and getting lower. So as one variable goes up and the other one's going down, that means we have a negative relationship. Before getting into our final topic, we need to go through a few important definitions first. So the domain of a function is the collection of all inputs of a function. The range is the collection of all of the outputs. So when we think about the inputs, we're talking about the independent variable, the x values. When we're talking about the outputs, we're talking about the dependent variable or the y values. As far as the bottom note goes, you'll see in a minute why it's important to understand that integers are whole numbers, where rational numbers are numbers that include decimals. A question you're going to see in this unit is what is the realistic domain and range of a relationship? Combining that word realistic with the definitions of domain and range tell us that they're asking us what realistic values could be used for both the independent variable, sprint time, and the dependent variable, long jump distance. So there's two things that we want to consider in this type of problem. We want to consider what type of number could appear as the input or the output. And we also want to consider if there's a logical lowest or greatest number that could appear as an input or an output. Let's do the domain first, which means we're going to focus on the x variable, sprint time. Since sprint time could include decimals, we're looking for rational numbers as our inputs. While there's no natural maximum amount of time it can take somebody to sprint a certain distance, there is a natural minimum of 0 seconds. Nobody can run a sprint in faster than 0 seconds. Putting these two ideas together gives us the realistic domain, that we're only looking for rational numbers, meaning it includes decimals, greater than 0 for the independent variable x. Now on to the range. So we're looking at long jump distance, or the y variable. Again, decimals are allowed for distance. You could have 1.5 inches. So again, we're dealing with rational numbers. You might be wondering if there's ever a time where it won't be rational, and there will be. Things like tennis balls or cups of coffee are things that we tend to round to the whole number every time, and that's when the answer would be integers. Once again, for this problem, there is no natural maximum. It might be unrealistic that somebody's going to jump 3,000 inches, but since there's no exact number that is the cutoff, we won't talk about an upper range. However, again, it's impossible for somebody to not jump at least 0 inches. So again, we would say that 0 is a natural minimum. Putting these ideas together again, we get that the realistic range would be rational numbers greater than 0. So to wrap up this lesson, let's get some quick closure. Linear regression is the line that best describes the relationship between two variables. The x variable is the independent variable, and the y variable is the dependent variable. There was a lot more in this lesson, so if you took anything else away, now is the time to write that down too. Otherwise, this lesson's over. See you next time.